Alright people, we're going to be looking at something called slope-intercept form, which is basically just an equation that expresses a linear relationship, which we've just finished looking at all during chapter 6, a bunch of linear relationships. So let me just give you an example of one of the linear relationships that we've seen. If you recall, linear relationships have a degree of 1. What that means is the exponent on the x is 1. Let's make a table of values here, and let's just fill it out for a bunch of values of x and y. Okay, so if we use these values of x, we get the corresponding values of y by just plugging in the numbers. So 2 times negative 2, for example, is negative 4. Negative 4 plus 5 is simply 1. And then you just kind of fill in the rest like that. And we know it's linear by looking at the slope, in other words, the rate of change. And what we said is even if we have points that are distributed unevenly like this, is that the rate of change is still the same. In other words, if you take this number and divide it by that number, it always ends up being the same. So 4 over 2 is 2, which is the same as 6 over 3, these two numbers here, which is the same as 12 over 6, which is the same as 32 over 16. They are all equal to 2. Well, basically, slope-intercept form just looks at this rate of change as being one of the definitive parts of an equation of a line, the other being the intercept, obviously. And so I wanted to kind of just point out to you one thing that's obvious here, is that this is the slope here, 2, and this 2 also appears there. So that's the slope. So if this is called the slope-intercept form, what do you think the intercept is? If you said 5, you're right. And then where do you see the 5 here? Well, I see it right there. There's a 5 there. Okay? Let's see why that's significant in another example. Okay, f of x is equal to negative 3 over 2x minus 11. I'm using the f of x, the function notation, just to solidify the stuff that we just finished talking about. So I can again pick values for x. Let me choose some for us. And I've chosen very conveniently all numbers of x that are divisible by 2 because it gives me whole numbers for f of x. So plug those numbers in, and that's what you get for the f of x, or for the y values, the output values. And again, let's look at the rate of change again. And we notice these are all equal to negative 3 over 2. Okay, so that again is significant because this negative 3 over 2 is right there. And then the negative 11 also appears right here. And what do you notice that's the same? If you notice that this 0 is the same for both, that is also significant because that is the point where x is 0 is where that graph crosses the y-axis. In other words, if we just look at this graph and put it on a graph, I plot those points on an axis, it would look like that. I just chose a bunch of points, and you'll notice that right here is where it crosses the y-axis. The coordinate of that point is 0, 5. Okay? And then if you wanted to calculate the slope, take any 2 points, say these 2 points here, and the rise over the run, well, 1, 2, 3, 4, 5, 6. 6 over 1, 2, 3. 6 over 3 is 2. Okay? And so that's where this comes from, and this is where that comes from. So the slope-intercept formula tells us the slope and the y-intercept for the linear equation, which makes it really simple to graph. For example, this other one that I asked us to look at in the beginning of the video, to graph that looks a little challenging because of the fractional slope there. But let's see if we can make this a bit simpler. Alright, I need a bigger graph here so I can fit all these points in. So let's first of all find the y-intercept. In other words, it crosses the y-axis at negative 11. So it crosses way down there. Now all you need is one other point to make the line. And I have the slope. Okay, so I can just apply the slope, which is a rise of negative 3 and a run of positive 2. which means I can go down 3 and to the right 2. So down 3, 1, 2, 3, over 2, 1, 2. There's one of the points there. I can go backwards, do the same thing. So I can go left 2 and up 3, and left 2 and up 3, and left 2 and up 3. And it gets really annoying, but also gets the job done. And so that's how I can make the line, graph the line, without having to pull out a crazy calculator and figure out what all those values are. I can just read them directly from the graph. So graphing linear equations that are in slope-intercept formula are really just kind of a fairly straightforward thing to be able to do. Let's do another one here. Okay, so if you want to have graph paper in front of you and you want to try to do this, I'll give you 3 seconds to graph this function, 4 over 7x plus 1. Alright, well, again, let's start with the y-intercept, which is plus 1. There it is right there. That's where it crosses the line. The other points are going to be on a slope of 4 over 7. In other words, the rise is 4, the run is 7. So count up 4. It's positive, so it goes up to the right, remember? So count up 4, 1, 2, 3, 4, and to the right 7. 1, 2, 3, 4, 5, 6, 7, boom. There's my next point. I can do the same thing going backwards. I can go down 4 and left 7. And my graph's going to end up looking like that. Okay, so graphing from slope-intercept form is just like that. So all those equations have the same format. They're all written in the same way, the same order. Okay, and that is we have y, or f of x, whatever, same thing, okay, is equal to the slope, which we gave the symbol m, if you remember from 6.5, m, which times x, my independent variable, plus some constant number, which is my slope, my y-intercept, sorry. So we say, and we assign the value b to it. That's a b, not a 6, believe it or not. There we go. Okay, there you go, b. Okay, y equals mx plus b is the slope-intercept formula. And it's just one of the ways we're going to be representing equations of lines. So all of this makes writing equations of lines very simple, because if you know the slope and the y-intercept, you can simply write the equation. In other words, it tells you, so I know it's y equals mx plus b. Well, m is the slope. This tells me the slope is 1/3. So 1/3 x. Plus b is the y-intercept. It tells me it goes through the point 0, 7. So it crosses the y-axis at 7. So it's plus 7. And that's it. That's the equation of my line. What I want to show you, though, is that this ordered pair solves the equation. In other words, you can plug in those values of x and y, and it makes the equation true. So in other words, if I make 7 equal to y right there, I go 7 is equal to 1/3 times, I'm going to take my 0, plug that in right there, instead of writing the x, and plus 7. Okay? And what you notice is you get 7 equals 7. That's a true statement. That means that that ordered pair solves the equation. And that holds true for any point on a line. Okay, just to prove my point, I've just selected some points for this function and I've graphed it. That's the line y equals 1/3 x plus 7. Let's pick some of these points, like -3, 6, and 9, 10. What I'm telling you is if you plug those points into the equation, you should get a true statement. Like if y equals 10, that would be like me saying 1/3 times 9 plus 7. 1/3 times 9 is 3. 3 plus 7 is 10. So that works. I can do the same thing with the other point. Okay? So that's going to allow us to solve some questions. If we know a point is on the line, it satisfies the equation. Okay, well let's say I asked you to find the equation of the line that had a slope of 2/3 and it went through the point 9, 9. I'm not giving you the slope-intercept, or the intercept this time, just the slope. Well, that point still satisfies the equation. I can fill in the slope, and that's the general form of the equation, but I can fill in the points 9, 9, and that will make the equation work. And you'll notice the only unknown here is b. And b obviously has to be equal to 3. In other words, the equation of the line is y equals 2 over 3x plus 3. And that's how we can write the equation of a line. Well, this one here, I haven't given you the slope or the y-intercept, but you can still figure it out because you can find the slope using the slope equation and then do the same technique as last time to find the equation. So pause the video right now, find the slope, and we'll see where we go from there. Okay, so to find the slope then, I just use the slope formula. Okay, in other words, slope is 3 over 6. In other words, 1 over 2. So that's my slope. So I know the equation is y is equal to 1/2 x plus b. I don't know what the y-intercept is, but I can plug in either this point or that point to figure it out. Let's use 2, 7. So y is equal to 7. 1/2 times 2 is 1 plus b. In other words, 7 is equal to, or pardon me, yeah, that's right, 7 is equal to 1 plus b, so subtract 1 from both sides, 6 is equal to b. So I can put that right there. Y is equal to 1/2 x plus 6. And if you don't believe me, you can double check. The slope is indeed 1/2, and it goes to the point 0.06, as well as those other 2 points as well. Okay? Alright, so for next class, I want you to find the equation of the line in slope-intercept form that goes to the point 4, 11 and -8, 2. I'll see you in class next time.